Assalamualaikum and hi to all my fellow friends and Puan Emilia. My name is Natira Najwa. In my video, I want to talk about topic 2B in our subject, which is measurement device. Okay, let we start. In this topic, we will learn about DC emitter. We have two kind of DC emitter, which is single rank DC emitter and two multi-rank DC emitter. This is single rank DC emitter circuit. So, RHS mean shunt resistant. RMs mean internal resistance or coil resistance. ISH mean shunt current. IM or IFSD mean meter current or full scale. Deflection current. I mean current range. Okay, next. Function of shunt resistor RSH in DC emitter. The basic DC emitter circuit can be constructed using a PMMC by connecting a resistor in parallel with the meter movement. The parallel resistor is called a shunt resistor, and its function to control the amount of current passing through the meter movement. This shunt resistance and PMMC can be thought of as forming a current dividing circuit. Okay, next, derivation equation for shunt resistor in single DC emitter. We have two kind of equation, which is voltage equation and current equation. Okay, this is our first equation, which is voltage equation. Vm equal to VSH, Im dot Rm equal to ISH dot RSH, RSH equal to Im, Rm over ISH, which is equation 1. The next equation is current equation. I equal to ISH plus Im, ISH equal to I minus Im to equation 1. Okay, the important thing is RSH equal Im dot Rm over I minus Im. So here we have example 1, a 2 meter movement with an internal resistance of 100 ohm is to be converted into a 0 until 150 mA. Calculate the value of shunt resistance required. Okay, in this question we have internal resistance, which is 100 ohm, meter current equal to 2 mA, and I current range 150 mA. Then equation to solve this answer. Im dot Rm over I minus Im. So RSH 2m multiply 100 over 150 m minus 2m. Then we got the final answer is 1.351 ohm. Next, to rank DC emitter, first the resistors are placed in parallel to give different current range. Then it's become two shunt, RSH1 and RSH2, and will give two different range of ISH1 and ISH2. Third, the selector switch S is multi-position switch is used for the range changing. Last, switch S also protect the meter movement from being damaged during range changing. This is two rank DC emitter circuit. When switch S are connected at RSH1, the amount resistance RSH1 and Rm are connected in parallel. Okay, next Using Ohm law, V equal to IR since it is in parallel connection. Vm equal to voltage drop across the Rm is equal. VSH1 equal voltage drop across the RSH1 and RSH1 equal to Im, Rm or I1 minus Im. And then the second, these two rank DC emitter circuit. At the first circuit, selector S is connected to RSH1 and the second is selector switch S is connected to RSH2. Using Ohm laws, V equal to IR since it is in parallel connection. Vm equal to voltage drop across the Rm is equal. VSH2 equal to voltage drop across the RSH2. RSH2 equal to Im, Rm or I2 minus Im. So here we have example 2. Design 2-rank DC millimeter with a basic meter having a resistance 75 ohm and full scale deflection for the current of 2 mA. The required ranks are 0 until 10 mA and 0 until 50 mA. Okay, the first rank is 0 until 10 mA. I1 equal to 10 mA. Im equal to 2 mA and Rm equal to 75 ohm. RSH1 equal to Im, Rm or I1 minus Im. RSH1 equal to 2m 75 in bracket or open bracket 10m minus 2m close bracket. So the final answer is 18.75 ohm. As you guys can see. Okay, we continue with our second rank is 0 until 50 mA. So give I2 equal to 50 mA, then Im equal to 2 mA and Rm equal to 75 ohm. Then RSH2 equal to Im, Rm or I2 minus Im. RSH2 equal to 2m open bracket 75 and close bracket or open bracket 50m minus 2m close bracket. So the final answer is 3.125 ohm. As you guys can see. This is 2-rank DC emitter alternation circuit. The equation for this topic, RH equal to R1 plus R2 plus R3. Okay, if the input is connected to position 1, it can be said that VSH equal to Vm, RSH equal to IM, RM, open bracket, I minus IM, close bracket, and open bracket, R1 plus R2 plus R3, close bracket, equal to IM, RM. The input is connect to position 2. It can be say open bracket I minus IM, close bracket, and open bracket R2 plus R3, close bracket, equal to IM, open bracket RM plus R1. Input is connect to position 3. This is position 3. It can be said that open bracket I minus IM, close bracket, and in bracket R3 equal to IM, open bracket RM plus R1 plus R2, close bracket. Next, we will learn about DC voltmeter. We have two kind of DC voltmeters, which is single rank DC voltmeter and two multi-rank DC voltmeter. This is single rank DC voltmeters. RS mean multipliers resistor or series resistor. IM means meter current or full scale deflection current. RMs mean internal resistor or coil resistance. V means voltage range. Okay, function of multiplier resistance RS in DC voltmeter. First, a basic voltmeter can be constructed from a permanent magnet moving coil instrument by connecting a resistor in series with the meters. Second, the series resistor is known as a multiplier resistor in bracket RS. Last, the purpose of multiplier resistance is to extend the voltage range of the meter to limit the current flow through PMMC meter to a maximum full-scale deflection current. Okay, next, derivation equation for series resistance in single-rank DC voltmeter. So this is single-rank DC voltmeter circuit. From voltage Kirchhoff laws, V equal to Vs plus Vm, V equal to Im Rs plus Im Rm, Im Rs equal to V minus Im Rm. The important is Rs equal to V over Im minus Rm. Okay, we have example 3. A moving coil instrument with a full-scale deflection 50 micro A and internal resistance of 500 ohm is used as a voltmeter. Determine the value of the multiplier resistance needed to measure a voltage range of 0 until 10 V. Rs equal to V over Im minus Rm 10 because we have 10 V and then 50 this and then minus 500, then we got 0.2 multiply 10, 6 minus 500. The final answer is 199.5 kilo ohm. Okay, this is the solution. Okay, next topic, two-rank DC voltmeters. First, the resistors are placed in series to give different voltage range. Second, the selector switch S is multi-position switch is used for the range changing. Third, when S equal to V1, maximum voltage range in bracket R1 plus R2 acts as a multiplier resistance RS. Last, when the switch S equal to V2, lowest voltage range in bracket, only R2 act as a multiplier's resistance Rn. Okay, this is multi-ring voltmeter series string. So in position V2, in bracket, lowest voltage range, the multiplier resistance is only R2. So here V2 equal to Im, open bracket, R2 plus Rm, close bracket. R2 plus Rm equal to V2 or Im. R2 equal to V2 or Im minus Rm. Next, two-ring DC voltmeter skirt. So this skirt switch is connected to V1. In position V1, maximum voltage range in bracket, the multipliers resistance are R1 and R2. V1 is equal to Im, open bracket, R1 plus R2 plus Rm, close bracket. R1 plus R2 plus Rm equal to V1 or Im. R1 equal to V1 or Im minus Rm minus R2. Okay, this is the last one in our topic, multi-ring voltmeter. This is multi-ring voltmeter circuit. Okay, before I end my video, I have last example. A moving coil instrument with an internal resistance of 50 ohm and a full-scale deflection current of 2 mA is to be used as a two-ring voltmeter. Design the multipliers resistors to obtain the voltage range of 0 until 10V and 0 until 50V. For position V2 equal to 10V, series multipliers is R2. So R2 equal to V2 over Im minus Rm. So 10 over 2 multiply 10 negative 3 minus 50. So the answer is will be 4.95 kilo ohm. This is for R2. Okay, next for position V1 equal to 50V, series multipliers is R1 plus R2. So R1 plus R2 equal to V1 over Im minus Rm. 50 over 2 multiply 10 negative 3 minus 50 ohm, and we get the 24.95 kilo ohm. Okay, then R2 plus R1 is 24.95 kilo ohm. So R1 equal to 24.95 kilo ohm minus R2 in 24.95 kilo ohm minus 4.95 kilo ohm. So we get the final answer is R1 equal to 20 kilo ohm. Okay, that's all from me. I hope you understand, and thank you.